In question 10, we're asked to graph four functions. They're not written in function notation, but there's, I'm sorry, three functions, right? A, B, and C. Probably the easiest one to graph is A, because it is written in slope-intercept form. So when I look at this, I understand two things right away, right? This has a slope of up 1 over 2, rise 1, run of 2, and it has a y-intercept that lives at the number -6. So it's pretty important when you're graphing functions like this to communicate with me or whoever's reading your graph what your scale is. And it could be as simple as just going 1, 2, 3, 4, 5, and then just putting the number 5 here. And I could go down 1, 2, 3, 4, 5, and then just make sure I know that that's -5. This, of course, is the origin. 1, 2, 3, 4. This is -5, and then 1, 2, 3, 4, +5. So technically, in the absence of this, right, I really don't have a way of evaluating if you've graphed the correct function or not. If you use a different scale, that's okay, but these are simple enough. Probably a 1-to-1 scale is your friend, unless you see a good reason why you might want to deviate from that. So that's adequate. You've totally communicated how this is set up, and I understand what's happening. So again, so we start with a y-intercept at -6. So I guess I'll do this one in purple. So right here at -6, we have a dot, and then we're just going up 1 over 2 units, up 1 over 2 units, up 1 over 2 units. And I don't need to do that a lot. If you don't have a little mini ruler, right, make sure I had them downstairs, and only a couple of people asked for them. Please use rulers when you're asked to graph these functions. So I have extended this line. The other thing I'm doing is I'm putting arrows here to very cleanly communicate that this is an infinite object and it's just getting started here. It goes on forever in both directions. So that is the equation of the line y equals 1/2 x minus 6. The next one, I think, caused all kinds of problems, right? There's a couple ways you can do it. You can get lucky and just guess some values of x, y that would make that equation true. So for example, if I said x is 0, it would have to be the case that y would be 4, I'm pretty sure, right? So if I'm just trying to come up with a table of values here, if x is 0, right, y would have to be 4 to get me to the 16. Okay, so I'll put a 4 there. If x was the number 2, 14 plus 2, it would, y would have to be the number, what would y have to be? That would be 14. 14 divided by 4 is not a nice number. It's not a clean number. Let me go to the number 4 instead. If x is 4, I need to get 12 more, so y would have to be 3, right? I think this is a fraction here, that's right. So I'm kind of guessing some numbers, and I could carefully plot those points and get the equation of the line. Probably a more efficient way to do this is to transform it into a form of the equation that we know how to easily graph. So for example, I could rewrite this as 4y equals -x plus 16. So you can see I've just subtracted x from both sides. And now I'm going to carefully divide everything by 4, right? So this becomes just y. I'm going to choose to write this as -1/4 of x, right? So you can see I'm showing it as a fraction because I want to look at what my slope pattern is, but it is x. It's 1/4 of what x was, so that got divided by 4. And then 16 divided by 4 is the +4, which is nice because I could see up here, right, my y-intercept was going to be at 4. So this is nice. I know my y-intercept is at 4, and I know my slope pattern is down 1 over 4. So this should be pretty easy to graph. Let me get this a little bit larger here. So again, we're going to start at 4, and we're going to go down 1 over 4 units, right? 1, 2, 3, and 4. And I'll just go down 1 more and then over 1, 2, 3, and 4. So with those 3 points, right, should pretty much be able to graph this. So I'm just lining my ruler up with the points and then just carefully drawing the ruler through there. And again, it's a very good idea to cleanly put nice arrows and indicate that this is a line and it goes on infinitely in both directions. The one question that was a little problematic was this last one, right? It says x is -5, and a lot of you told me that there's just not enough information to graph that. But I'm asking for a line in which this is always true. X values are always -5. A couple of you graphed the line y equals -5. That was horizontal. But if I was to look at this carefully, here's my x-axis, right? On this point right here, x is -5. And some of you just graph that single point. But it turns out if you go below that, right, here x is -5, y is -2. Here x is -5, y is -5, right? What's important about this line is everywhere where I land on this line, right, even though y is changing, y is positive up here, right, no matter where I go, x is always equal to -5. So that's why this is the line x equals -5. And it's the only equation that we have to write in this x equals form, right? We can't write the equation of a vertical line in y equals form because the slope of that line is undefined, right? It doesn't have a slope. Whereas a horizontal line has a slope that equals 0, that line has a slope that's undefined. So this is the equation of the line x equals -5. So those were the three functions we were looking at for question number 10.